Looking at probability of independent and dependent events. Has anyone heard the words?
Yeah.
Okay, alright. You've probably heard them in like a sense of like maybe a scientific variable or something. This is not related to that. So just looking at the difference between the two, independent events is when the outcome of one event does not affect the outcome of the other event. Dependent events is when the outcome of the first event affects the outcome of the other. I remember this specifically with like a question about socks. I remember in 8th grade. There was a question about socks where like once you wore the pair of socks, you didn't have that pair of socks anymore in the drawer, and so that lowered the sock count. So that number will change after the first event. That's what makes it dependent. If you look at these probability, does it say what's different about this than we had yesterday? And B, right? It's not A or B. Remember, or was an addition. When it's A and B, we'll be multiplying the probability of the two events. Okay, same thing here. A and B will be multiplying the probability of the two events. This really, all this means right here, it means probability of B given that A has already happened. So like basically your numbers are going to be different on this because the event A already happened, and therefore our numbers are going to change on this. But again, you're just multiplying the probabilities. For the first section, we're just trying to figure out whether they are independent or dependent. Okay, so looking at the first one, it says rolling a 1 and then rolling a 6 on a number cube, so like a dice. So like the fact that I rolled a 1, is it going to change my numbers? No, that's independent. Those have no effect on each other. Independent. Okay, a bag has a red and 2 blue marbles. First one blue marble is drawn and then replaced, and then a red one is drawn. Okay, so if we replace it, are we affecting how many marbles there are the next time? No, there'll be the same number of marbles. So again, that's independent. And what made it independent is the fact that it was replaced. If we didn't put it back, then it would be dependent because we would have less marbles when we go to pick next time. But we replaced it, which makes it independent. The probability that it will rain tomorrow and the probability that the baseball team will have a rain delay. Yeah, that's dependent. I'd say those two are very much related to each other. Dependent. In a bag with 5 white marbles and 5 black marbles, Sanjay pulls out a white marble without returning the marble to the bag. Sanjay pulls out a second marble. What was the key word? Without returning the marble. So when we go to pick another marble, our numbers are going to be different, which makes it dependent. Okay, for the next section, we're going to actually be calculating it. This for each of the following, determine if the events are independent or dependent. So we have to figure out whether it would be independent or dependent. And then we'll actually calculate the probability. In a survey at the pep rally, 50 of 75 males and 40 of 50 females said they would favor a new team mascot. If one male and one female are randomly selected, what is the probability that they both favor a new mascot? That's independent, right? They have nothing to do with it. Just because a female fan and a male fan, like if the male fan says he favors it, it has nothing to do with what the female is going to say. Those are not related, so that would be independent. Okay, so what we're trying to calculate is we're trying to calculate the probability of the male favoring a new mascot, male favoring, and the female favoring the new mascot. Forgot how to spell female for a second. Okay, starting with male favoring a new mascot. What would be my probability? 50 out of 75, because there's 50 out of 75 males said they would favor a new team mascot. 50 out of 75. And means I need to multiply. What would be my probability of females favoring a new mascot? 40 out of 50. Y'all remember we can actually simplify before we multiply. Does this reduce it all? It does. It reduces a lot. 50 and 50, because remember you can reduce diagonally. The 50 and 50 would both reduce to just a 1 and a 1. And then 40 and 75 are both divisible by 5. What's 40 divided by 5? 8. What's 75 divided by 5? 15. So we're not left with a whole lot left to multiply. We have 1 times 8 on the top, and we have 15 times 1 on the bottom. 8 out of 15. So that's almost half. Almost half. And for the second one, a 6-sided dice is rolled and a coin is flipped. Find the probability of landing on heads and rolling a 6. Is that independent or dependent? Independent, right. What you roll on the dice has nothing to do with what you flip on the coin. One of them will not affect the other, which does make it independent. Okay. So we're trying to get probability of landing on heads and rolling a 6. Probability of heads and rolling a 6. Okay. Remember, Anne's telling me I need to multiply the two of them. So starting with probability of flipping heads on a regular old coin. 1/2, because there's one head and 2 sides on that coin. Probability of rolling a 6 on a regular dice. 1/6, because there's 1/6 out of 6 sides. Can I reduce it all before I multiply? No, that does not reduce. So we'll just do top times the top, which is 1. Bottom times the bottom, which is 12. Doing okay? Alright, 5 days of Spirit Week. During each of the 5 days of Spirit Week, a student is randomly given 1 out of 10 prizes. All prizes are available each day, and one of the prizes is a $50 gift card. What is the probability that the student receives the $50 prize at least once? It is independent. Why is it independent? All are available each day. Very good. That makes it... All prizes are available each day is what makes it independent. Okay, so we're going to start with that. Alright, we actually had a question very similar to this yesterday. It's this right here that says at least once that makes it a little tricky. This would be like a bonus question. Okay, we had one very similar to the, do y'all remember the very similar one on yesterday's notes? You don't. Oh, I'm so proud of you. Okay, so for a situation of at least once, we used the complement. The complement would be 1 minus the probability of what? Yeah, not winning it. The opposite of winning it at least once would be the probability of never winning it. Never winning it. Okay, so we're using our complement. 1 minus. All right, let's think about probability of never winning it. How many prizes are there? There's 10, right. And how many of those would be losers? 9. So on that first day, there's 5 days of Spirit Week. On that first day, if we're never winning it, that means we'd be getting 9 out of those other 10 crappy prizes. Well, maybe they're not crappy. Okay. Second day, 9 out of 10. It doesn't change, right? Because it says the same prizes are available each day. We would just never win it. The next day, 9 out of 10. How many days are there? You could do to the 5th power. It's not squaring it, but it is an exponent. Try it.
Why wouldn't you just do that?
Well, there's nothing wrong with learning how to do multiple ways, Danny. Alright. Okay, what is that? 1, 2, 3, 4, 5. 1 minus 9/10 to the 5th power.
Also, it's easier because the 1 just stays a 1.
1 minus 9/10. What? Oh, yeah. That's why I put them out. Alright. Oh, I like 40%. Okay, that's not bad. 1 minus 9/10 to the 5th power. What'd you get? Can we change it to a decimal? No. Cool. Okay. So. Or, sorry, yeah. Can we change it to a fraction? No. It says not allowed. 0.40951. I guess we'll leave it as a decimal. We could also write it as a percent. 40.951%. Is that what you got, Danny? Is that what you got? When you did your magic method?
I don't get it.
He didn't do it. Wah, wah, wah. So this would be the probability of getting it at least once, because it's the complement of never winning it. Alright, next one. There are 8 shirts in your closet. There's 4 blue and 4 green. You randomly select one to wear on Monday and then a different one on Tuesday. What is the probability that you wear blue shirts on both days? It is dependent. Why is it dependent? You're not putting anything back. Very good. You wear that shirt and then it does not go back in your closet. It goes in the dirty clothes hamper. So that would be dependent. Okay, so we're trying to figure out probability that you wear blue shirt on both days. So probability of blue and probability of blue given that we already wore blue on the first day. Blue and blue. I'm going to call that again. But again, we already wore blue on the first day. All right, starting with our first probability of blue. How many total shirts are there? 8 shirts. How many are blue? 4. Okay. So my probability of wearing a blue shirt the first day would be? Don't reduce it yet, but 4/8. Very good. 4 blue shirts out of 8 total shirts. And now the second one, the dependent number. My numbers are going to change because I no longer have 4 blue shirts. What else do I no longer have? I no longer have 8 shirts total. Very good. Now I have 3 blue shirts and 7 shirts total. I had 1 fewer here and 1 fewer here. Okay. Does anything reduce before we multiply? No. Maybe the 4/8 you could reduce to 1/2 if you wanted to. And then if you do top times top, bottom times bottom, we get 3/14. What would that be as a decimal so we can see what it would be? Like 21%. 21% probability to wear blue shirts on blue. If he's what? Yeah, because he might wear that dirty shirt again. Alright, card questions. Where's my card information? What? I love card questions. Alright. You randomly select 2 cards. Come on, boys. You can make it. 2 cards from a deck of 52 cards. What is the probability that the first card is a heart and the second is a club if you replace the first card before selecting the second card? Independent. What makes it independent? You replace it, which means we have exactly the same number of cards. Independent. Okay. So we're trying to find probability that the first card is a heart and the second is a club. So probability of heart and club. All right. Probability of selecting a heart. How many are there? There's 13 out of how many total? 52 total. 13 out of 52. And is telling me to multiply probability of selecting a club. Also 13 out of 52. Very good. We replace it so we have exactly the same number of cards. Okay. Do either of those reduce beforehand? Yeah. Yeah, they technically both reduce to just 1/4. So 1/4 times 1/4 is 1/16. 1/16 is like 6.25%. Yeah, is that low just because there's a lot of cards? So. We'll say that 6.25. Actually, it's not approximately 6.25%. It's exactly 6.25%. Okay. And then what if we don't replace the first card? Hold on. If we don't replace it, is it still independent? No, now it's dependent. Okay. So that means probability of heart and probability of club, given that we already selected a heart. Probability of heart. Hold on. And club, given that we already selected a heart on the first one. Club, given that we selected a heart. Alright, starting with hearts. We know that probability. What was that again? 13 out of 52. And telling me to multiply. Very good. Club, given that we already selected the heart, we still have 13 clubs, but Honor said we don't have 52 cards total. Now we have 51 cards total. Very good. So just one fewer total. Okay, 13 over 52 does reduce if you want to reduce it first to 1/4. I don't think any of this reduces. 51, I believe it is. No, it's not prime. Never mind. Top times top would be 13. No, it divides by 3. Bottom times bottom would be 204. Let's see what that would be as a percentage. 13 out of 204. 6.37-ish%. What was hard about that? What was hard about that? The moral of the story is don't gamble. Those are not winning numbers there. Alright, one last little challenge one. If we're having sidebar conversations, let's pause our sidebar conversations for 5 minutes to get through this. Alright, suppose your area has 8 different service providers for internet. Y'all know what a service provider for internet is? Verizon, AT&T, Xfinity. Okay, you and your 3 friends randomly select a provider. What is the probability that you all choose different providers? What is the probability that you all choose different providers? No, because it doesn't have the at least. It doesn't have like at least this amount. Okay, is this independent or dependent? It's dependent. Yep. For every person that already chooses, there's one less provider. Okay. So we're trying to find the probability that we get a provider and then we get a different provider. I'm just going to call that B. And that we get a different provider. How many people are there total? 4. There's 4 people. and that the last person also gets a different provider. So I'm just calling them different letters just to help keep it clear in my head. Okay, so for the first person that goes, there are 8 providers and they can choose from 8. Which is 1, yeah.
And then 7 out of 7.
And then not 7 out of 7, 7 out of 8. There's still 8. We just don't want them to get the ones they can choose from are fewer now. If you do 7 out of 7, then you would just, yeah, you would have 1 times 1 times 1 times 1, which is definitely not a 100% chance. 7 out of 8 total. So here's just total providers. Internet peeps. And then this would just be the number basically that you can choose from in order to get a different one. Choose from. Okay, so the next person, third person goes. They only have 6 to choose from in order to get a different one. And then last person, 5 out of 8. Feel free to reduce any and all that you want to reduce beforehand. I know this is definitely 1.
6 out of 8.
6 over 8 would be 3 over 4. I don't think anything else reduces anywhere. Alright, so if we do all of our top times top times top, 7 times 105. Out of 8 times 8 times 4. Very good. Let's see what that would be as a percent, just out of curiosity. 41%-ish? 41%?